Hello, I'm Svetlin Naku from SoftUni, and this is the next episode from my Dev Concept series. In this lesson, I will briefly explain and demonstrate the concepts of data structures and algorithms in computer programming with live code examples. As an example, I will demonstrate the tree data structure and the DFS algorithm, the recursive depth-first search traversal. Data structures are representations of data in the computer memory, which allow efficient access and modification. This is a pretty big topic. Hundreds of books are written about data structures. Data structures can be linear structures such as arrays and lists, tree-like structures such as balanced trees, graph-like structures such as graphs, hash-based structures such as hash tables, and others. Linear data types are the most commonly used data structures in programming. They represent sequences of elements which can be ordered or not, indexed or not, linked to the next element or not, etc. Examples of linear data structures are arrays, lists, tags, and queues. This is how arrays and arrays-based lists look like in the most programming languages and platforms. They are sequences of elements which are directly accessible by their position and which is called index. This is an example of linked list. It consists of elements where each element's node is next element. The last element has no or missing value as next element. Unlike array-based lists, linked lists do not provide direct access by index. This is an example of array-based queue. This is the queue data structure, which works on the principle FIFO. First in, first out. Elements are appended in the queue at its left end. At its back, this operation is called enqueue. Elements are taken from the queue from its right end, from its front. This operation is called dequeue. We shall master the linear data structures in detail in the advanced programming modules of SoftUni. This is a simple example which illustrates the list data structure. We have a list of numbers representing a sequence of income amounts. This is how the list looks like in the memory. It is an indexed structure. Each element has a unique index, a number in the range from 0 to the size of the list minus 1. This is how we can append a new income, and this is how we can modify an existing income by its index. This live demonstration illustrates how to use simple lists in JavaScript. We open the live example at repo.it and we wait for it to load. It needs some time. This is the same example from the previous slide. We run it and we see the result, the list before and after the modifications. In programming, sometimes we use more complex data structures like trees. Trees and tree-like data structures consist of nodes, where each node holds data and a list of child nodes and parent node. This example illustrates visually a tree. This is a tree holding the directory structure of a hard drive in Windows. The root node, C:\\, has three child nodes: programs, users, and Windows. The child node users has three child nodes: Maria, Peter, and George. The other nodes have no children. Each node except the root have a parent node. Data structures often come with algorithms for their processing. Such algorithms can be different styles of traversing or appending, inserting, deleting, or modifying a node, extracting substructures, finding paths, and much more. Examples of algorithms are the classical tree traversal algorithms, depth first search, DFS, and breadth first search, BFS. We shall learn them in the Data Structures and Algorithms module at SoftUni. The sample pseudocode implementation of the depth first search algorithm in the in-depth traversal starts from certain node. Then this node is first printed. Then traversal starts immediately recursively from each child node of the current node. The traversal process initially starts from the root node of the tree and reaches all the three nodes sooner or later. Unless the tree has a cycle or the tree is not connected, this process of traversal is finite and will traverse all the nodes. Print. This live example demonstrates the tree traversal algorithm, depth first search. DFS used to traverse the local file system. Let's see it in action. We open the live code example at repo.it. Now we wait for it to load, as usually. And we can see the source code of the example. The code is a little bit longer and a little bit more complicated than in the previous example, but essentially this is the DFS algorithm implemented in C#. The sample code starts the directory tree traversal from the parent of the current folder and traverses recursively the file system under this folder. Let's run the program. The output holds all the files and subfolders of the current folder at the server side listed recursively. In this lesson, I cannot teach you how to traverse trees. Instead, I can demonstrate important development concepts such as data structures and algorithms, and this is just a small example of how an algorithm may look like. I hope you find it interesting to learn more about data structures and algorithms, and later in your learning track for programmers.
Hey, did you like this lesson? Do you want more? Join the learners community at softuni.org. Subscribe to my YouTube channel to get more free video tutorials on coding,
dev concepts, and software development. Get access to more free dev lessons and learning resources for developers. Get free help from mentors and meet other learners. And it's all free! Join now, softuni.org.